Hello and welcome to this week's video. Now, due to some technical difficulties, we won't be doing the Design in Any Parametric software series for this week. I do hope it'll come back next week. And also, you won't be able to see my face. Bummer, I know. What we are going to be doing, though, is we're going to be bringing back the Alibre Design Tips and Tricks series back, but with a huge video, right? This is going to be a long one, and it's going to be a good one. It's also going to be advanced, so it's going to be hard. So I guess you could say that this is a long and hard video. Now, what are we going to be doing? Well, Alibre cannot do threaded forms for 3D printing, right? Where you actually need the external thread to be there. It doesn't have a tool for it, but we could make a tool for ourselves, right? And we can make it quick and efficient and nice and all of that. So first I'll show you how I'm going to make these three threads on these three poles. Okay, I'm going to use the tool I've already made, and then I'm going to show you how to make it. Okay, so first of all, we go to the Boolean subtract environment. We're not going to select anything. Okay, there you go. And then, while we're in here, we're going to go to the library and generate. Okay, so what have I done here? I've created the CAD threading die. Okay, so let's see. 6 by 1. Yeah, that's fine. That's fine. Finish. Let's leave that here. Let's generate another one. Threading dies, right? It's how you would make threads in a lathe. Okay, so this is 1.25. Yep, 1. There you go. Let's make all of them 20 millimeters in length. You can see that this is an option as well. Oh, yeah, finish. And then let's do the final one, which is these are just names, right? This is the M10 that counts. Okay, by 1.75. No, but this is by 1.5. Okay, let's finish. Let's leave it there. So these are our thread dies. So what do we do now? We go back to the Boolean and we start constraining, right? This is how the Boolean environment works. You use the same constraints as you do in an assembly, and then once you're done, the system just performs the Boolean operation that you initially selected. We initially selected subtraction, so now it's going to subtract. Okay, subtract, and 3D threaded forms, 3 different specs, all done correctly, all, you know, stopping and finishing beautifully, really nice for 3D printing. Plus, with this method, you can control your own tolerances, right? And you can parametrically control your tolerances. So I'll show you how all of that can be done. Okay, I mean, this didn't take too much time to make 3 fully formed threads. So I'll show you how all of this is done, and hopefully you'll get an insight on how the library works as well. So how do we do that? Well, first you need to design your Boolean threading die. Okay, so let's start doing that. Yeah, let's not do that. Okay, I'm sorry guys for this back and forth, but first you need to make your variables, right? You can start the sketch, stop it, make variables. This is just a better workflow. So let's start here. I'm going to create a variable called mthread, and I'm just going to give it a value of 12. So this is my nominal diameter of the thread, right? I'm just going to call it 12. Okay, I'm just going to call it mthread and give it the value 12. So then I'm going to create another variable which I'm going to call pthread. This is going to be the pitch, and I'm just gonna say that this is 1.75. Okay, and then I need a third variable. I'm gonna call it length. This is the overall length of the thread. Okay, let's hit OK. Now this is a great explanation. It's the Wikipedia page for isometric screw threads. So you see that in order for screws and nuts to thread, properly, the thread must not be fully formed, right? You need these gaps here, right? And what we need to do is we need to calculate this h value, right? What is this h value? This is the height of the thread profile, and the thread profile for most metric and imperial threads is an equilateral triangle, right? So triangle has all of its angles equal to 60, so all of its sides are equal, right? So this value h is the height of that triangle, and geometry tells us that that value is the cosine of this angle here, right? The angle theta, which is half the included angle of the thread. The idea behind it is that you take this equilateral triangle, you draw the height, splits it into two right triangles, and then what is the height? Well, it's the cosine of 30 degrees times the pitch, right? But this side is also the pitch, so it's cosine times the hypotenuse gives you the adjacent side of the triangle, right? So that's how I do it. I'm guessing this is correct as well. So another variable we're going to need is the height of the thread. I'm going to call that thread h. Okay, and thread h is the cosine of 30 degrees times the pitch of the thread, and I can tell you right now this is going to be a mess. This is going to be a ridiculous value. Apply. And that's wrong. The reason this is wrong is that Alibre takes radians here. So whenever you want to convert radians to degrees, you write the degrees here, and then you say multiply by 2, multiply by pi, and divide by 360. Okay? And if you check, now that's the correct value, right? So we have these four variables that we will need to design with. Now we can start our sketch. So I'm going to make a circle here, right? This is going to be of a diameter M12, and I'm going to turn this into a reference line. So you can either click on it and right click and then convert to reference figures. I have hotkeyed this command so I can do it from the keyboard directly. Okay, so this is going to be a guide. Now we want an outer circle, and the distance of that outer circle to the inner circle is something that I will select. Bear in mind that this needs to be small enough so that you can make threads in tight spaces, but large enough to use the bonus trick I will show you at the end. So 5 times the P thread. Okay, this is large enough to use the bonus trick. I've been using it. It's okay. So this is the outer circle of our thread die. Now let's make the inner circle of our thread die, and let's think. Okay, if this works like a threading die, the inner diameter of it, the innermost diameter of it, is going to be what? it is going to be the minimum diameter, right, of our external thread, because then we'll do a helix and create the major diameter, but this is going to be the minor diameter. Okay, let's go back to our Wikipedia page. And if you see, right, this is our external thread, so the minor diameter is 1/4 of the thread height away from where the profile would end theoretically. Okay, so that's how long that is. Okay. So let's think about implementing that, right? So we go back here. Now this is our nominal diameter. Okay, nominal diameter, by the way, is the theoretical point where the profile would meet up here, right? So what's the distance between this theoretical point and this actual minor diameter? We have this is our reference 12 millimeter circle, and we want to create a circle that represents this line here. That's easy. That's 3/4 of h, right? That's parametric. Let's go do it. So this is 0.75, right? Another way you could do it is 3 divided by 4 times, I'll give you 0.75. The thread height. The thread height. Okay. And if you wanna, if you wanna know where you're standing, we can have a driven dimension showing you what is this minimum minor diameter, right? This is what you're going to get. Now, if you want to make this larger or smaller, here's where you're going to be doing it, right? And if we open the equation editor, we can add a tolerance. Just going to call it tall, and you give it a value 0.01, right? So this is something. I hit escape and it didn't. Yeah, I do that all the time, guys, all the time. Okay, so this is a value that you can add or subtract or do whatever you want with, and then control it parametrically, right? So what do I want this? I want this to be lower, so yeah, plus, okay? Even smaller minor diameter, right? And if I go back to this equation editor and turn this into 0, I'm working with the regular values. So I'm not going to be specifying a tolerance for this example, right? You can play with the tolerances, see what works with your 3D printer, and put it in there. So again, to recap, what is this sketch? I'll create a reference circle at my nominal diameter. I want an outer diameter that's really large, right? Definitely a lot larger than this. So what I usually do is 5 times the pitch. That gives me an adjustable outer diameter. For the inner diameter, which is going to end up being my external thread's minor diameter, right? So the difference here is, oh, is it? Yeah, yeah, no, it makes sense. It's 3/4 of the thread height plus a tolerance if you want to have an even smaller minor diameter. Obviously, if you use a negative tolerance, the minor diameter will be larger, and so on, right? So how did we arrive at this? Well, we know that this tip, this theoretical point that the standard profile ends, that's our 12 millimeters, right? Okay, let's make it a bit larger. So here's our triangle, 1, 2, 3 lines. Okay, this point is our 12 millimeters. Okay, and the height of this theoretical thread profile is what we calculated to be 0.866 and a bit times the pitch. Okay, so that's how far inside your nominal diameter the thread will come. Okay, but we also said that, look, we want to take 1/4 of that height off. Okay, we want to cut it off. So that's how we arrived at this value of 3/4 of the thread height plus a tolerance that, you know, is of our choosing. So that's how we end up at this sketch. Okay, now we close the sketch and we extrude that by how much? Well, I think you guessed it, by the length. Okay, this is one of the parameters that we want to make. Okay, now before we go on to make our thread, we want, on the side that we sketched, right, we want to add a chamfer, and that chamfer, not in the entire face, just here, that chamfer needs to be relatively large. So what I do is I make it equal to the pitch of the thread. So this is large enough. Okay, this is good enough. Right, so this is step 2, and now step 3 is we create our helix. In order to create a helix, you need a profile, and then you need the parameters of the helix, which you input in there. So let's make that profile. Okay, I'm gonna open my plane so I know where I'm sketching. So I'm gonna want to sketch in the YZ plane. Okay. Now, what is our profile? Well, we know what our profile is. It's a 60-degree triangle. Okay, so we have our triangle. We make every side equal. We make, you know, one of the sides horizontal. Okay, then we size it. Now this should be equal to the pitch thread. Okay, but here you can also input a tolerance. Okay, by making this slightly shorter, will make your threads looser. So minus that tolerance. I've made the tall value equal to 0, so that's not going to make a difference for me. I just hit OK. There you go. And then you make these 2 points vertical. Okay. So so this triangle now can go up and down. Where should it sit? Well, we know that this is the theoretical end of our thread. So this needs to be at a diameter of 12. Here I'm specifying the radius, so divided by 2. Okay. Is that it? Well, it's not, because if we go back to this shape here and we make it bigger again, we don't want our thread to go all the way up to this theoretical point. We want to chop off 1/8 of the thread height. Okay, and how do we do that? Well, I'll show you. Let's make this smaller again. We go here, we select these 2 lines, turn them into reference lines, okay, and then make a line on this one, horizontal one, back again. And this distance is going to be 1/8 times the thread height, right? And that's it, guys. We're good to go. This is our profile. This is good enough, right? And if you also look, I know it's a bit hard to see. Maybe if we, yeah, there you go. You can see that the profile, right, does not end on the inner surface here, right? Yeah, this is the 1/4 of the thread depth that we chopped off. Okay, so every spec checks out. We're good to go. Okay, let's hide the sketches again. Select sketch 2 and subtractive helix. We want the height and pitch type as a reference line. We'll select the outer cylinder here. Now the height is going to be equal to the length. Okay, I want to make sure that the threads go all the way to the end of this cylinder, so I'm just going to add 2 spirals more with the correct spelling. And what is the pitch of the helix? Well, it's the pitch of the thread, right? Now, if we were making a tapered thread, we would select the taper here, and of course we would have made that a parameter as well. For tapered threads, you better make the taper of the thread a parameter as well. And there you go. Well, that looks like an M12 thread to me, right? Well, at least a threading die. A CAD specific threading die. Okay, so we made it. Okay, now we want to save it. And I'll select a folder here. And this is going to be threader Boolean 2. Okay. And now, after I have saved it, because anything that goes into the library needs to be saved, right? I go to the library menu and I hit add to library. And what happens is Alibre opens up a table for me and tells me which are the values that you want to have the library dynamically change. Okay. Now, the only values that are necessary to create this shape is the nominal diameter, the length of this thread, and the pitch. Okay, the thread height is a calculated value, as is everything else. If you also want to be able to dynamically change the tolerance, just include that as well. I think that if you find a number that works with your 3D printer and you just hard-code it there, it should work. It should be fine. But if you want to change it every time dynamically, just include that as well. That's a preference of yours, right? So we select these 3 strictly necessary values and we hit next. And we're shown a table, okay? So the way these work is... Oh, what happened there? Windows, man. So, and we are presented with this table, right? To create the dynamic properties that we're going to be creating. Okay, so from left to right, this is the display order. Okay, actually, I want this to be first, then the pitch, then the length. Okay, cool. This is the display name, so this is what will be, this is the title of the variable that the user will see, you will see. I want to change this to pitch, I want to change this to length, and this I'm going to leave like that because I'm not actually going to be using it, okay? So, why am I not going to be using it? Where in metric threads, it's relatively easy because the nominal diameter for an M12 is 12 millimeters, right? For an M8 is 8 millimeters, and for an M7, which is a suboptimal metric thread, would be 7 millimeters, okay? But in the imperial system, there are some cases where that doesn't really correspond. So, for example, a half pipe tapered thread, or even a straight, an NPS half-inch pipe thread, does not have a nominal diameter of a half an inch. Okay, half-inch NPS thread means it's a thread for a pipe with half an inch of working diameter. So the inner diameter of the pipe is half an inch. The half-inch NPS thread is actually closer to 20 millimeters. So how do we handle that distinction, right? So we'll make another, we're going to make another variable which is only going to live in the library, right? And we're going to call it nominal thread, right? And we're going to drive this, right, we're going to drive this value from the text input in this value. Okay, I'm going to do it for metric threads. If you can't figure out how to do it for your imperial threads, just reach out and I'll reach out in the comments and I'll explain it. Okay, so what do we do here? So here we make a list of values. Okay, in a system where the decimal point is a comma, you need to use a semicolon here. If your decimal point is a point, you just use a comma here. It's the same behavior as in Excel, if you're familiar with that. So these are the available text inputs, right, that I will make. When using these separators, either the semicolon or the comma, whichever is appropriate for your system, what it tells the library is that this is going to be a drop-down menu, right? So you just made a drop-down menu with these available values. And then we're going to go to this M thread, this nominal diameter value, and we're going to say, this is not an input, this is value-driven. Okay, click to edit, right? So the driving parameter, which parameter will drive my nominal thread diameter? Okay, that's the nominal thread parameter that I just made. So how do you populate that? Hit plus, right? I'll give you the first value it sees, 1, right? Plus, click in here, we'll give you the next one, 2. There we go. So there seems to be an issue here. Okay, well, let's make this numeric and this numeric as well. For some reason, it's telling me I made a mistake here. And I cannot find the mistake. So let me look, and you'll come back with me when I do find it. Okay, so the problem there was that for some reason the parent parameter needs to be higher up in the display order than the parameter it's actually driving. Okay, so yeah, just do that and you should be fine. Okay, so display name, let's put a gap in there so that it makes more sense. I took out that gap, that space, see if that was a problem. It wasn't, so let's put it back in so it makes more space. Again, these are display names, right? This is what the user or you will be looking at when making the selection. And finally, you just tell it where to put it in these folders, right? You can create custom folders with custom names if you go to manage library ahead of time, right? I'll just put it here. This is the standard folder which I changed the name of it. Finish, and I'm good to go now, right? Now this part is in my library. Good. Okay, so let's go back here. Right? I'll delete that Boolean command and I'll do it again. and we hit the check mark, and we've got our Boolean operations. There you go. Right, there you go. Now you've got threads, okay? Threads that you can print. And now for the bonus trick, you can clearly see that I'm just going to make a nut. But the thing is, I'm just going to use the same threading die that we made earlier. So how do I do that? I go to the Boolean commands again, and I do a Boolean intersect. I won't choose anything from here. I'm going to go to the library and generate a part. And by the way, this is going to be an M4 nut. Okay, so I'm just going to call it M4 nut bool tool. Why not? It's just a file name. Select everything. M4 by 0.7, I think it is. The length I just need it to be larger than the thing I want to create the threads in. So yeah, hit finish here, go back to the Boolean. Now what I want to do is I want to make sure that the part I want to create the threads in is completely encased in the threading die. In this case, I can still make this coincident. As a best practice, I propose to you that you just give it a bit of offset, right? Hit apply. Then we need to make that coaxial. 0 offset this time, right? Okay, now it's fully encased, right? The nut is fully encased in the threading die. And again, it's a Boolean intersect, so if I hit the check mark, we got our threads. That's how you can make female threads with the same library generated tool. Also, another thing that you need to know, when you save this, okay, it will also save a part that is the part that you generated in order to make the threads. Now that's a good thing because you save this, okay, then you can open it up, okay. Let's open that part and see what's happened here. Okay, so this is what we generated, okay. So what the design library does is it creates an instance, and then as you save it, it crystallizes the equations. Okay, here's the 4 that we selected through our nominal thread drop-down menu. The nominal thread variable is not here, as you can clearly see. Okay, let's do something stupid and let's change the thread to 1 millimeter. Okay, also you can change the tolerance. Okay, so if we hit OK, you see that this thing changed dramatically. We save that. We need to close this file and reopen it. You will see that the threads are going to be drastically different. Okay, there you go. Hugely different threads. Okay. So what that means is that for every different thread that you get in a part and that you create a Boolean die to make, for every different thread that you have there, you will have a different part generated that you can then open and play with the tolerances separately. Okay, separate tolerances for every single of these parts. And if you want to have different tolerances for male, female, you can even create a different library parts, or you can just do this little trick here, change the tolerances accordingly. It gives you so much flexibility, So fully formed threads very quickly and with the ability to change tolerances for each thread separately. Okay, so that's it for today. Subscribe if you want more videos like that. Hit like if you liked it, hit dislike if you didn't. I still want to know if you didn't like it. And please leave a comment saying what you did with this little trick, right? What you made with it. I really want to know.
Thank you, and I hope I see you next week.